Hello dear students. I hope you all are in the best of your health and enthusiastic about your studies. Students, today we are going to study chapter number 6 of class 8th science, that is combustion and flame. So first of all, let's see what you already know. Can you name a few fuels used in your homes? What are some fuels used in automobiles? What is CNG? What are the differences between burning of a candle or burning of a fuel like coal? Now let's see what we are going to discuss in this chapter. Combustion, types of combustion, flame, fuel and efficiency of fuel. Let's study all these topics one by one in detail. First of all, let's start with combustion. In class 7th, we had performed an activity in which magnesium ribbon is burnt to form magnesium oxide and produced heat and light. Now, we are going to perform a similar activity with a piece of charcoal. Hold the piece of charcoal with a pair of fire tongs and bring it near the flame of a Bunsen burner. We find that charcoal burns in air, producing carbon dioxide, heat and light. In this way, a chemical reaction or a chemical process in which a substance reacts with oxygen to give off heat and light is called combustion. The substances are of two types. Some substances can burn easily and some do not burn. For example, here you will observe that one boy brings a burning matchstick to a paper and other brings a burning matchstick to a piece of glass. The paper started burning easily. So, children, those substances that can be burned easily in the presence of oxygen to produce heat and light are called combustible substances. On the other hand, piece of glass could not catches fire. So, the substances that do not burn in the presence of oxygen are called non-combustible substances. Now, let's discuss about the conditions which are necessary for combustion. Fix a lighted candle on a table. Place a glass chimney over the candle and rest it on a few wooden blocks in such a way that air can enter the chimney. Observe what happens to the flame. Now remove the blocks and let the chimney rest on the table. Does the flame flicker off or does it flicker and give smoke? Again, observe the flame carefully. Finally, put a glass plate over the chimney. Now, let's understand some more facts about combustible substances. Here you can see that a boy is taking a burning matchstick towards a piece of paper. And second boy is taking a burning matchstick towards a piece of wood. But this piece of wood does not catches fire easily, whereas paper catches fire and starts burning. It means the piece of wood does not reaches to its ignition temperature. So, dear students, the lowest temperature at which a substance catches fire and starts burning is called its ignition temperature. That is why different substances catches fire at different temperatures. You must have observed that you all have been stopped by your elders to bring mastic near LPG stove. Why is it so? Because LPG gas easily catches fire. It has a very low ignition temperature. Similarly, you must have been observed signboards of no smoking at petrol pumps. Can you think why? Yes, because petrol also have very low ignition temperature and it can easily catches fire. Similarly, smoking is also prohibited at petrol pumps. So, dear students, ignition temperature of petrol and LPG is very low and they easily catches fire with a flame. That is why these substances are called inflammable substances. Now let's see how can we control fire. But before, it is important to know about the conditions which are necessary for burning. First thing necessary is the combustible substance or fuel. Second one is air and third is heat to raise the temperature of fuel beyond the ignition temperature. Fire can be controlled by removing one or more of these requirements. That is why if we cut off the air supply to the burning substance, fire can be controlled. You must have observed firemen to extinguish the fire by throwing water under pressure on fire. Water cools the combustible substance below its ignition temperature, and this prevents the fire from spreading. But water has some limitations. Water cannot be used to extinguish fire in electrical equipments and wiring because water is a good conductor of electricity. So it can cause electric shocks to the people involved in firefighting operations. Similarly, water cannot be used to put out fire caused by burning of oil or petrol because water being heavier than oil settles down at bottom. So, carbon dioxide is the best fire extinguisher for fires involving electric equipments and inflammable materials like petrol, etc. Carbon dioxide, being heavier than O2, surrounds the burning combustible substance like a blanket. In this way, it cuts off the contact between the burning combustible substance and oxygen supply, and the fire is extinguished. So, dear students, the added advantage of carbon dioxide is that In most cases, it does not harm the electrical equipments. But now, question arises that from where we can get the supply of carbon dioxide. Carbon dioxide gas can be stored at high pressure as a liquid in cylinders. When released from the cylinder, carbon dioxide expands enormously in volume and cools down. So, it not only forms a blanket around the fire, but also brings down the temperature of the fuel. That is why it is an excellent fire extinguisher. Now, dear students, let's see the types of combustion. Depending upon the conditions under which combustion takes place, there are three types of combustion: rapid combustion, spontaneous combustion, and explosion. Let's see what is rapid combustion. When a combustible substance burns at a rapid rate, producing a very large amount of heat and light, is known as rapid combustion. Spontaneous combustion. When a combustible substance burns into flames on its own without the application of any apparent cause, is called spontaneous combustion. Explosion. When a substance burns and a sudden reaction takes place with the evolution of heat, light, and sound, and a large amount of gas formed in the reaction is liberated, it is called explosion. Children, can you tell what is a flame? If we observe a flame of kerosene lamp, the color of the flame looks yellow. Whereas if we observe an LPG flame coming out from our cooking gas stove, it appears blue in color. Color of candle flame depends on supply of oxygen. If supply of oxygen is less, then the color of flame will be yellow. It means the process of burning or combustion of fuel does not complete it. But if the supply of oxygen is sufficient, then the color of flame becomes blue. It means here combustion of fuel completed. So dear students, now question arises here is that why flame occurs? Let's find the answer. The substance which vaporize during burning gives flames. For example, kerosene oil and molten wax rise through the substance and are vaporized during burning and form flames. So, at the time of combustion, the substance which vaporize on heating burn with a flame. On the other hand, charcoal is a solid fuel which does not vaporize on heating. So, charcoal does not burn by producing a flame. It only burns in combustion. Now, dear students, let's discuss zones of a candle flame. A candle flame can be divided into three zones. The innermost zone which is black zone, middle zone, which is called luminous zone, yellow in color, and the outer zone, which is non-luminous zone, that is blue in color. Let's perform an activity to understand three zones of a candle flame. Take a lighted candle. When the candle flame is steady, introduce a clean glass slide into the luminous zone of the flame. Hold it there with a pair of tongs for about 10 seconds and then remove it. You will observe a circular blackish ring is formed on the glass slide. It indicates the deposition of unburnt carbon particles present in the luminous zone of the flame. That is why this zone of the flame is also called middle zone of partial combustion. Let's do another activity. Hold a thin, long copper wire just inside the flame for about 30 seconds. You will notice that the portion of copper wire just outside the flame gets red hot. It indicates that the non-luminous zone of the flame has a high temperature. It is the hottest zone of the flame and is called outer zone of complete combustion. That is why goldsmiths blow the outermost zone of flame with a metallic blowpipe for melting gold and silver metals. Dear children, do you know what is fuel? The materials which are burnt to produce a large amount of heat energy are known as fuels. Wood, coal, LPG, kerosene, diesel and petrol are examples of fuels. Now let's discuss the characteristics of an ideal fuel. It should be fairly cheap and easily available. It should be easy to handle, safe to transport and convenient to store. It should burn smoothly and not produce any harmful and irritating fumes during burning, and it should not leave ash after burning. So dear students, now we will learn about fuel efficiency. Fuels are the important sources of energy. We use petrol to run automobiles. LPG is used at homes for cooking. Crude oil is used as fuel in aeroplanes. Wood or coal are used for different purposes like get warmth at our places, etc. Children, all these are the examples of fuels. All fuels produce different amount of energy. The amount of heat energy produced on complete combustion of 1 kilogram of a fuel is called its calorific value. The calorific value of a fuel is expressed in a unit called kilojoule per kilogram. Children, Do you know that burning of fuels leads to harmful products? Let's discuss about some harmful products produced during burning. The increased use of fuels has several harmful effects on the environment. For example, carbon fuels like wood, coal, and petrol on burning releases unburnt carbon particles which cause severe air pollution. These fine particles are dangerous pollutants causing respiratory diseases such as asthma. Incomplete combustion of these fuels gives carbon monoxide gas. It is a very poisonous gas. It is dangerous to burn coal in a closed room because the carbon monoxide produced can kill persons sleeping in that room. Combustion of most fuels releases carbon dioxide in the environment. Increased concentration of carbon dioxide in air is believed to cause global warming. Burning of coal and diesel releases sulfur dioxide gas. It is an extremely suffocating and corrosive gas. Moreover, petrol engines gives off gaseous oxides of nitrogen. Oxides of sulfur and nitrogen dissolved in rainwater and form acids. Such rain is called acid rain. It is very harmful for crops, buildings, soils, and for animals too. Now, dear students, let's revise this chapter. Oxygen in air is essential for combustion. Ignition temperature is the lowest temperature at which a combustible substance catches fire. Combustion is mainly of three types: rapid combustion, spontaneous combustion, and explosion. There are three different zones of a flame: dark zone, luminous zone, and non-luminous zone. Fuels differ in their efficiency and cost. Increased percentage of carbon dioxide in air has been linked to global warming. Dear students, now let's discuss some questions and I hope that you all know the answers. So first question, I have some substances and you have to tell which of these substances burn with or without flame. The substances are candle, naphthalene balls, a metal piece, coal, gas stove, and cotton. So, we know that candle burns with a flame, naphthalene balls burns without flame, coal burns without flame, gas stove burns with flame, cotton burns without flame, and metals burns with flame. Second question, differentiate solid, liquid and gaseous fuels from these fuels. And the fuels are dung patties, kerosene oil, LPG, coal, diesel and natural gas. Yes, you can make a table here. Solid fuels are dung patties and coal. Liquid fuels are kerosene and diesel. And gaseous fuels are LPG, that is liquefied petroleum gas, and natural gas. Now here are some fill-ups. Which gas is directly linked to global warming? Yes, carbon dioxide gas. The use of diesel and petrol as fuels in automobiles is being replaced by dash. By which gas? Yes, you are right. That is CNG, compressed natural gas. It has replaced diesel and petrol as fuels in automobiles as it is a cleaner fuel. So dear students, here we come to an end of this chapter, that is combustion and flame. I hope you understood the chapter nicely. So dear students, keep safe, keep healthy, keep studying and keep discovering new things. We'll soon meet with another chapter. Thank you.